So I'm Gareth Rushgrove. I'm Gareth R nearly everywhere on the internet. I also talk very quickly, and I've got lots to get through, so hopefully this is going to be a good audience to go quickly. I do a newsletter that some people might subscribe to. If you're not on DevOps Weekly, you should be. Personal plug. I've written a lot of Puppet code over a whole bunch of years. I now work for Puppet Labs, so I'm biased, but I do other things as well. Who in the room is using Puppet? Hands down. Who has been using Puppet but isn't today? Cool. Thank you. This is a very, very quick introduction to Puppet, then I'll get on to what I'm talking about. Infrastructure as code, whether it's files or packages or services or it's users or groups or it's all the other things you manage on your server, let's describe them in code and let's have code review and tests and fight over that rather than running individual scripts. Puppet has a mechanism where there's generally a Puppet server with like Puppet on the agents. We'll store information in tools like PuppetDB. We'll write modules that are sort of analogous to the cookbooks that Stephen was just talking about. And we'll use tools like Hiera to describe sort of the data part of the code. There's a lot of bits and pieces, a lot of moving parts, but we're building up an ecosystem of like individual tools that work together well. If you want the really sort of what is Puppet, like come see me afterwards. That's the very fast version. I'm here to talk about the sort of the future in 4 sort of small bits that I think are interesting. Hopefully you will too. I'm going to talk about sort of network devices. I'm going to talk about sort of cloud infrastructure that that's the bit I'm mainly working on. I'll try not to just take up all the time with that. I'm going to talk about sort of the Puppet language itself, and I'm going to talk about sort of a move to more native clients. So I said I'd go quickly. I think it's easy to see sort of like tools like Chef, like Puppet, like Ansible, like everything, sort of CF Engine. We should have CF Engine here. As tools to manage sort of packages and files and services and users and groups and the things that we manage on hosts. And they are, but we've got pretty good at doing that. And so the things that we complained about 2, 3, 4 years ago are not the things we're complaining about today. And one of the things that crops up is if you're working somewhere where there's hardware, it's like, oh, it's great. I've got all this code to manage my like hosts. And I have to go see this other team to manage my network. And it's not their fault. They just have really not very good tools. So what we're increasingly doing is using the Puppet language, the Puppet domain-specific language, to configure network devices. So for those that haven't seen Puppet code before, this isn't a particularly interesting example, but it is an example of using it for managing something maybe you haven't thought about managing with Puppet before. I'll fly through a bunch of sort of like GitHub things. I'll probably just go click next. They're sort of there for reference. This code's all out there. It's not all written by Puppet Labs. Though that part that's the sort of network standard library. Something that's not is actually, you might be managing, who is managing hardware in here? Yay, there's still some hardware people. Excellent. If you're managing sort of NetApp storage things, let's describe that in a domain-specific language. Rather than having to go see someone and have a sort of an opaque conversation, like let's have a pull request that we can, and code review that we can have a conversation about. Let's turn the rest of our infrastructure into code. That's from a chap down in Bristol. And not lots of people put their hands up about hardware because maybe you've sort of moved past that. You're post-hardware. You're running cloud infrastructure. Or you're running devices that sort of are much more of a distributed system. I'm a big fan of actually both ETC and console for sort of different reasons. But we can manage those in code as well, rather than, like, they both provide a way of storing key value pair information. So let's not put it onto disk. Let's put it onto a distributed key value store. That's great. We now don't have to have a file on every disk that has to be there. We can just store it in a nicely resilient distributed system. The nice thing about doing that in something like Puppet is that we can do things like this. We can swap the provider out for the other one. We have a unified interface to two tools that, broadly speaking, at the key value pair side of things, are doing the same thing. And that's quite compelling if you're in an environment which either moves quite quickly or eventually changes its mind about tools. Maybe you're moving from Zookeeper to console. Maybe you're moving from console to Zookeeper. Let's try and have a single user interface to sort of simple functionality. One of the other areas I think is really interesting, and I said I could go on this for a long time, is sort of management of cloud infrastructure. Increasingly, we're using, whether it's Amazon, whether it's Azure, whether it's VMware stacks, whether it's OpenStack, we're setting those environments up. They become the sort of some of the primitives that we worry about. How many instances do I have? Do I have any security groups that actually shouldn't be there anymore? Is my VPC set up in such a way that everything can talk to each other? Puppet at its heart is a domain-specific language for describing a graph of things that relate to each other. It happens to be that the implementation that most people have seen is to use that to manage files and packages and services. But why not manage instances in EC2 in Puppet? Why not manage security groups and load balancers? And actually, much more interesting than instances is managing auto-scaling groups and managing the VPCs. And you don't have to manage the entire stack. You can use it purely as an auditing tool as well. So I'm spending a lot of time doing that. If anyone's really interested in that, come see me afterwards, because I'm looking for people to sort of do some user testing. But it's not just about single providers. It's about different providers. We can provide the same types of things for different APIs, like DigitalOcean. We can provide the same sorts of things to stand up Koros clusters in DigitalOcean, because that will give you a 3-node Koros cluster in a very short amount of code. If you want another node, add Koros 4 to the list. We can start describing higher level infrastructure concepts in code, as well as the low level stuff. And you can imagine this could go on for a while with different providers, but I won't do that. And it's not just like the high-level cloud providers. We can do things with Docker. I can't remember, Stephen didn't even mention Docker. How did he get away with that? This is something actually that I did prior to joining Puppet Labs and I'm now maintaining internally. Like all of these different things, whether it's on a host, whether it's on a cluster, whether it is the cluster itself, we can describe in code. And that code is the Puppet language. And we've seen sort of a few examples, and some people will be more familiar with Puppet as a language, as a domain-specific language. But it's evolving alongside this effort. And I think lots of the examples people will see are sort of quite key-value pair-esque. That's great from a simplicity point of view, but sometimes you want more power. And one of the things that's happening there is that moving the Puppet language from, there's a reference implementation, there's the application Puppet, go have a look at it, to an actual language specification. So if you're the type of person who sort of geeks out over the academic language side of things, we have an actual spec for the Puppet language now. And that gives us a bunch of interesting things we can do around tooling, that other vendors can do around tooling, that we can do around multiple implementations of a compatible language. So I definitely have a look at that. Part of this is turning into what's often referred to as the future parser in sort of Puppet land. That has things like optional types. So yes, it's based on a Ruby implementation, but we can have actual types in here. We can say this has to be an array, not just, oh, it should sort of look like this. We've got iteration and lambdas in there. So we can do things like each. We can do things like sort of filter and reduce. We've got concatenation, appending, chaining, assignments, error handling. We've got more language features. Puppet is turning into much more of a powerful domain-specific language. It's still not about sort of it being Ruby or it being Java. It's a domain-specific language for describing a graph, and that graph has applications in infrastructure management. You can use these features now if you're running sort of relatively recent versions of Puppet. It will be the default in the coming sort of Puppet 4.0. There's lots of stuff to like in there. So you can just pass parser future, and you've got that now. It's worth testing your modules, if nothing else. See how your code works. And if you're coming to Puppet fresh, I would probably start there because there's a lot of sort of interesting power. There's a whole bunch of documentation. I think if people are used to Puppet, hopefully you like the docs. If not, tell us about it. And if you really want the skinny, Henrik Lindberg, who has done a lot of this formalization, has done a lot of the language design, has a Puppet on the Edge blog that's, if you're a computer science person, read it. It makes you cry. The other big thing that's happening in the sort of Puppet domain is sort of where moving away from using Ruby as the core language for Puppet everywhere. So Puppet as a thing has started out in Ruby. And we're still using Ruby for a lot of extension things, and we're still obviously maintaining the Ruby code base. But we're moving a lot of the agent side of things to C++. And everyone was probably thinking he's going to say Go or Rust if you were really cool. Or Camel if you were really cool. It turns out C++ is not as bad a language as I thought, which was good when I found out about this. Auto is amazing. You don't have to know everything ahead of time. Part of the reason behind this is, for the language choice at least, is we support a really wide range of platforms. We want Puppet to be ubiquitous. We want Puppet to run everywhere. And we have a surprising number of users using AIX. We want to be on hardware. We want to be on your switch. And no one is going to put a Ruby runtime on your switch, for very, very good reasons. A big part of this is even if you're not running hardware, even if you're not running AIX, who's running AIX? Hey, we love you. It's about, we want Puppet to be like NTP. You don't worry about the NTP daemon. It's about being faster, but it's actually about being just memory usage, about CPU usage, being quiet. We've started this work by porting factor, which is basically a fundamental part of the sort of Puppet chain, to C++ to prove that we could do this, really. This is shipped now. This is available now. You can toggle this on if you install the factor packages. They're available in our nightly repos. And it's I'm using this quite a lot for just sort of inventory. It's much faster, but it's also much less busy. And if something like Puppet is going to be everywhere and it's going to be running all the time, it needs to be a lot quieter, and that's where we're heading. On the server side as well, we're starting to take much more advantage of the JVM. Here we're actually using quite a bit of Ruby, but we're running it under JRuby. We're actually using a lot of closure to support that. That gives us a whole bunch of sort of different sort of characteristics. And again, we can deal with, a lot of it's about dealing with sort of those error conditions in a much more predictable fashion. Yes, the JVM might need more memory to get it started, but it deals with that memory, it handles that memory much more efficiently than the Ruby runtime does once it gets up to speed. Again, the Puppet server is available now. It's heading towards a 1.0 release. You can run that now. It's part of the commercial Puppet offering as well, so web, it's fully supported for if you're paying us money. The really interesting stuff, I think, comes with the native Puppet agent. When are we getting there? We're working on it. It's an open source effort, so if you're sort of a burning desire to write some C++ or learn a new programming language that's literally will run everywhere, that's something we're heading towards. So, in conclusion, hopefully I haven't gone too quickly. With Puppet, we want to be everywhere on everything. We want to be ubiquitous. We want to be a dumb bit of software you install everywhere. We want a good language above that allows you to do all the things you do in your job, not just manage those individual hosts. If you haven't ever used Puppet, the Learning VM is a great place to start. If you have, it's actually a pretty good sort of refresher of some of the things that are coming. And I think everyone sort of, hopefully, that's sort of, whether you've used the software or you've not used the software, or whether you've like actually started to use something else, we have a lovely community. There's a lot of people to ask lots of questions, so please come join us. And if you like sort of like the look of a bunch of this stuff and you'd like to be involved in finding out what's coming up, sort of not just from talks, and you'd offer us a bit of sort of feedback on some of the stuff we're doing, we have a user testing group called Test Pilots that if you're interested in that, come see me and I can get you set up on. You find out stuff a bit early and you get to give us feedback, so everyone wins. And there's lots more to come. Like, this is the 20-minute version of what we're up to. Admittedly, I can talk quite quickly. So I don't think there's time for questions here, but